All right, day 2 of vectors in the plane. So back of your other sheet, you could probably take notes on this. I don't have a nice notes sheet for you, but it can kind of go with the existing notes that you have from Friday. That way you've got them all in one spot. Same section, just more information about it. Okay, so writing the component linear combination form of a vector given the magnitude and direction. Okay, kind of similar to what we just saw on question 41 when we worked that one out. We have a vector with a horizontal component of A and a vertical component of B, and we are given the magnitude and theta. Okay, we're trying to figure out what those values are. Remember that when you build your right triangle here, we have an A, that's the horizontal, B, that's the vertical. And so if we were trying to find the direction of this, the direction angle of this vector, what would we do to find the direction angle? Use the tangent, because the tangent is the opposite and the adjacent. And so the tangent of theta will be B over A. So far, so good? Okay. And how did we find the magnitude if we were given A and B? Yep, the magnitude of a vector is the square root of A squared plus B squared. Simply by Pythagorean's theorem, right? Okay, so we're using the stuff that we knew from 2 chapters ago and the stuff that we've known since beginning of time, algebra, I guess, to figure out those values. Okay, well, it turns out then that if you want the vector in a nice, neat, orderly format, what you can do is you can say, okay, my A value, well, first of all, my A value will be the vector times the cosine of A. Okay, the magnitude times the cosine of A, because if I want A by itself, first of all, I went a step ahead too quickly. If I want to get A, the cosine of A is, or the cosine of theta is the adjacent over the hypotenuse, A over the magnitude. Okay, to get the A by itself, we take the cosine of theta times the magnitude, and we've got our A component, our horizontal component. Okay, if we want the B value, that is, we're going to use sine. The sine of theta is the opposite over the hypotenuse, B over the magnitude of the vector. And to get the B by itself, we would multiply both sides by the magnitude. So the magnitude times the sine of theta. Okay, that's the component form. What does the linear combination form look like? That's the one that didn't have the chevrons, right? The linear combinations look like AI plus BJ, right? Right? So AI plus BJ, if I want my A, it's cosine of theta times the magnitude. Okay, so it will be the magnitude of the vector times the cosine of theta, I, plus the magnitude of the vector times the sine of theta, J. Okay, and I think I have a build here that's going to pull in. Oops, went too fast. Okay, so those are the two forms. Did I lose anyone on this? The I and the j are just another set of variables that are used specifically for component and vector form. Just like we typically use v's and u's for vectors to name them with a bold face. I and j are simply I is the horizontal movement and j is the vertical movement. Just another way of writing the same thing. Did you all see vectors at all in geometry last year? Not in this form? Because we taught it this year, but we're in new books, so I need to kind of know how comfortable and familiar you guys are with them. Okay, not much. Okay, okay. Okay, so a vector, if you weren't here on Friday, a vector is something that's more than just a number, because a vector has both a magnitude, a length, and it has a direction. Okay, so we started talking about directed line segments, meaning that they have a specific length. How long is it? What's its distance from the origin, if it's in standard form, to its endpoint? And also, what direction is it going? So we have two pieces to that vector, an angle and a magnitude. Okay, so when we're working with those types when we're working with vectors, we have to kind of keep in mind that it has two components. We need to know in which direction did the car peel out and how fast did it do it. Okay, in which direction is tension being put on someone's leg in traction and how much tension. Okay, that's what vectors are all about. There's two pieces to them all. Okay, if you don't have the angle right when you're putting someone in traction in the hospital, you're going to do damage to their leg, right? If you have too much tension or not enough tension, you're not going to help the leg out. Okay, all right, so when we are to find a component form and we're given the magnitude and the direction, component form is the one with the chevrons. Okay, it says what is your horizontal movement? That's your A value. What's your vertical movement? We like to call that our B value. Okay, so we have a magnitude of a vector that is 2. Okay, its length on a directed line segment is 2. So if it helps you to see it, to visualize it, here's our origin. In standard form, this vector is going at a 45-degree angle, and its magnitude is a total of 2 units. I did not draw a 45-degree angle very well with my smartboard orientation. Okay, let's try that again. Okay, so all we're looking for here is what would be the ordered pair of that endpoint. Okay, what is the x value and what is the y value of that endpoint? We write that in vector component form with chevrons. Okay, a chevron, yep. Okay, so it's bigger than a greater than sign. Okay, and that is basically a special notation for and a bigger than a less than sign. Okay. Okay, so in order to find the components of that, we need the A and the B. Okay? We can do it in a couple of different ways. Okay? We say, all right, A is going to be this guy, right? B is the height. And we just developed a formula for it, right? The magnitude of the what? Cosine. The magnitude of the magnitude times the cosine. Let me rewrite it so we get to see it and become familiar with it. The magnitude times the cosine of our angle, comma, the magnitude times the sine of our angle. Okay? So our magnitude in this case is 2. They told us it was 2 units long. Okay. We know our theta is 45. So this will be 2 times the cosine of 45. And then 2 times the sine of 45. We know off the top of our heads the cosine of 45 is square root of 2 over 2. So 2 times the square root of 2 over 2. 2 times the, what's the sine of 45? Square root of 2 over 2. 2 over 2's cancel. We get the square root of 2 and the square root of 2. That's the component form of a vector with magnitude of 2 at a 45-degree angle. Questions you have on this one? Just plugging them into that formula. Okay. So far, so good? All right, so this next one says, hey, I want you to have a magnitude of 3, but I want you to be in the direction, this new vector is going to be in the direction of negative 3i plus 4j. Negative 3i plus 4j will not have a magnitude of 3. Why? What's negative 3 squared plus 4 squared? 9 and 16, 25. This one's got a magnitude of 5. Square root of 25 is 5, right? But we want it to have that same direction angle. Make sense? So the same direction angle, the same theta as this one, but use magnitude of 3. So how do we find the direction angle for negative 3i plus 4j? It helps you to visualize it, draw it out. Negative 3i plus 4j is very similar to our chevron notation, just a linear combination form instead. But what did we do? We went 3 in the negative x direction. Okay, we think of this as being the I and the j, and 4 in the positive j direction. So here is our vector in standard form. Okay, so if this is negative 3, 4, how do we find the theta, the direction angle, from the positive x-axis? Tangent of theta equals 4 over 3. Okay, always going to be the b value over a. And good question. Why is it not negative 3? Okay, we have to remember that when we work this out, we can certainly put the negative 3 here. Okay, we'll get a negative value. We have to know what to do with it. Okay, it's just a side of a triangle, and that's why we typically wouldn't say it, but that's okay, because this is negative 3 in the I direction and 4 in the j direction, right? You can make it positive, and that's okay, but what we have to remember is that whatever we get when we put 4 over 3 and inverse tangent in our calculator, that's not the theta we're looking for. Okay, that's 180 degree removed from the theta that we're looking for. Okay, 180 minus that. So let's go with our lovely 4 divided by 3 inverse tangent on your calculator. If you want to work in degrees, make sure that you're in degrees. So the inverse tangent of 1.3 repeating gives us a 53.13 degree angle. And if you had left it as negative 3, it would tell you it was a negative 53.13 degrees. Yep, 180 minus it if it was positive, or add 180 to it if you had a negative. and we get 126.87, right? The second tangent of 4 over 3. Yep. So 126.87 degrees. That's the big one. That's this theta right here, which is what we've defined our direction angle to be, is the angle from the positive x-axis. Okay. So we have our direction angle now. Okay. Theta sub v is 126.87. And we have our vector, right, or our magnitude of vector. Okay. So how do we find the, and since it was in linear combination form, we'll put it back in linear combination form. We're going to have what? Our magnitude times the cosine of theta, magnitude times the sine of theta, right? There's going to be a plus possibly, or maybe a minus, depending on how we end up. Okay. So what's the magnitude? 3. What's the cosine? And in this case, up here, we knew these guys off the top of our head, right? But down here, we don't. So we're going to make sure that we plug them into the calculator. We'll end up with a decimal, and that's okay. Okay. So 3 times the cosine of 126.87, I, plus 3 times the sine of 126.87, J. So cosine of our answer times 3. Everybody get a negative 1.8 I. And then 3 times the sine of 126.87, 2.4 J. That should be your answer. It should be in the same direction as this vector, and it should have a magnitude of 3. What does the answer mean? That it means that this particular vector went negative 1.8 in the I direction. Okay, think of it as having an I and a J instead of an X and a Y. Okay, so it went 1.8 left and 2.4 up, and it started at the origin. That was this beginning point, and there's this ending point. So it should look very similar to what we had over here, just not nearly as long. That was, so you had a magnitude of 3. Yep. This one is very similar, but it had a magnitude of 5, because 3 squared plus 4 squared would get me 5 squared. Okay, so they're in the same direction. They have the same theta, but this one only has a magnitude of 3. Okay, it's like pulling on something with some sort of tension, right? And this one has less tension. It's in the same direction, pulling on a piece of a part or something like that, but with less tension. Okay. So far, so good. What questions do you have? Taking time to warm up to vectors, aren't you? They're a little different. Okay, next question, or next problem then. So first of all, next we want to find the component form of the sum of u and v. So we'll review a little bit of what we did on Friday. Okay. The nice thing about component form of vectors is they added nicely, didn't they? if I had A and B for one of my vectors and C and D for another one, when we added them up, we got A plus B and C plus D. That's the easy stuff. But they told us now we have a magnitude of 4, and the angle, direction angle for U is 60 degrees. V has a magnitude of 5, and its direction angle is 90 degrees. So let's get them both into component form and then add the components up. How do we find the component form of something with a magnitude of 4 and a direction angle of 60? And 4 times the sine of 60. Okay, we know the cosine of 60 is what? Should know that one off the top of our head. 1/2. Okay, cosine of 60 is 1/2, so 4 times 1/2. And what's the sine of 60? So 4 times the square root of 3/2. So 4 times 1/2 is 2. 4 square roots of 3/2 reduces to 2 square roots of 3. Okay, let's find the component form of a vector with magnitude 5 and direction angle 90. 5 times the cosine of 90, 5 times the sine of 90. What's the cosine of 90? 0. 5 times 0 is 0. 5 times the sine of 90. What's the sine of 90? 5 times 1 is. So when we want to add these up, we add the horizontal movement and we add the vertical movement. And we're done. Andy, put it away, please. Probably one of the hardest units you'll have to learn. Okay. Questions that you have on this one? We're good? All right, so applying vectors. Probably done some of this in physics class. Okay. Hopefully this is similar to the way that they teach it in physics and you can just build on that. Okay. So forces with magnitudes. Okay. When you think of a magnitude, think of your newtons. Your newtons are your magnitudes. Okay. Forces with magnitudes of 2,000 newtons and 900 newtons act on a machine part at angles of 30 degrees and negative 45 degrees respectively with the x-axis. Find the direction and magnitude of the resultant of these forces. When we see the word resultant, what does that mean we're going to do? It was in your notes on Friday. What did resultant mean? The sum of two vectors. So we want to put these guys in component or linear combination form. And when we're all done, we want to add them up. Okay, so far so good? Okay, so we've got a force that has 200 newtons. We'll let that be our U. Okay, the magnitude of U is 2,000. And it has a direction angle of 30 degrees. The magnitude of V is 900 newtons. And its unit vector, or its directional angle, is negative 45 degrees. So how do we find u in component form? 2000 cosine 30. 2000 sine of 30. Okay. Cosine 30 is square root of 3 over 2. So 1000, 2000 times the square root of 3 over 2. 1000 square root of 3. Okay. Sine of 30. 1/2 times 2000. Okay. Let's work with V. If we have 900 newtons for our magnitude and our direction angle is -45, 900 cosine -45, 900 sine -45. Okay, so far so good. Okay, what's the cosine of -45? Okay, and if -45 would be down in the quadrant 4, right? So is it going to be positive or negative? Positive. So we'll have 900 times the square root of 2 over 2. And then sine of -45. What's the sine of 45? Square root of 2 over 2, right? But it's going to be in the fourth quadrant. Sine is negative there. So 900 times a negative square root of 2 over 2. Okay. 900 over 2 will be 450. So we've got a 450 times the square root of 2 and negative 450 times the square root of 2. Okay. We're ready to add them up. So when we add up u plus v, bless you, we will get 100, 1000 square roots of 3 plus 450 square roots of 2. And then we'll get 1000 plus a negative 450 square roots of 2. Okay. Let's store this as A in our calculator, and let's store this as capital B in our calculator. Okay. Everybody know how to store things in their calculator? Yes, no? No? Okay, let me show you that. Get to the right spot here. There we go. All right, calculator on. Make sure it is in radian mode, or degree mode, sorry, degree mode. Okay. Degree. Yep, we'll work with degrees this time around. Okay, so we're going to take 1000 times the square root of 3. And we're going to add 450 times the square root of 2. Let me put a parenthesis here. Okay. And that should be a plus, right? Not a times. All right, so 1000 square roots of 3 plus 450 square roots of 2. When we press enter, you get 2368.45. Make sure my notes are, or that's the right number in my notes. Okay, we're going to store that in A. Okay, to store that in A, Do you see the store button just above on? Okay. It's going to be stored in, and then you hit alpha A. And A I can't see on my screen very well. Is it a shift of math? Okay. So we're storing that in A. Press enter, and it went into A. Okay. Now we're going to do the B part of this. We're going to take 1,000 minus 450 square root of 2. 1,000 minus 450 times the square root of 2. Thank you. Way to watch me. Okay, that's going into B. Okay, so we're going to hit the store button and alpha B, which is right next to A. So we've got 363.60 in B now. Is anybody on the calculator? Okay. So we're to find the direction and the magnitude of these forces. Okay. When we want the direction, what trig function did we use? Okay, to store it. Once you have it, you hit the store button. Okay, and then say second and A. Or sorry, alpha and A. My fault. And then A should be this guy right here. And then press enter. Okay, then all we have to do is go to our alpha and get it. Right, right. And that's okay. It's just giving you answers. So we've stored the answer for this into A. We've stored the answer for this into B. Okay? How do we find the direction angle? Tangent. Okay? So we want the tangent, inverse tangent of A over B, don't we? Okay? So we say second tan, and then we go alpha A divided by alpha B. Sorry? Should be, I'm sorry, it should be B over A. We want it should be B over A. My fault. Second B over second A. Okay? So this is an 8.72 degree angle. Okay? Now we have to use our A squared plus B squared to find our magnitude, right? So we say square root of alpha A squared I can't see my buttons on my calculator, plus alpha B squared. Bless you. And there's our resultant force. That's the resultant. That's the force, or that's the magnitude. And magnitude in newtons. 8.73 degrees and 2,396 pounds, or newtons. Yep. Yes, sir.